this video, we're going to look at a complete factoring guide. So we're going to try to go through every single type of factoring, minus a few that you'll see. So these are going to be really mainly for Algebra 1 and Algebra 2 type of factoring. So let's go ahead and start. So the first type of factoring we want to look at is factoring out a GCF. So a GCF just means a greatest common factor. Now, what factor really means, or at least the way I view this part of it, I think about what's the biggest number, so biggest number that I can divide. So that I divide, we'll just say divide out, okay? So when I hear greatest common factor, once again, I just think, what's the biggest number that I can divide out? All right, so now let's look at a problem and we'll look at what this actually breaks down and looks like. So let's say we have, let's go with 12k minus 18. And our job is to find or factor out a GCF, which I left out my, there we go, GCF. All right, so first you're going to start with your numbers. So our numbers, or the coefficients, I just say numbers because it helps me understand it. So numbers are 12 and 18. So I want to find the biggest number that divides both 12 and divides 18. And that number would be 6. So my GCF right now is 6. Then I'm going to look at my variables. Now, this one's a pretty easy one because this term 12k has a variable k, but 18 does not. In order to factor out a variable, all your terms have to have that same variable. So we can't factor out a k here, so my GCF is 6. So here's what I do. I rewrite 6 outside of a parentheses, but what goes inside the parentheses is when I actually divide out 6. So you're going to divide both your terms by whatever your GCF is. So this would give me 12 over 6, which is 2. I would bring down k. I would bring down my minus sign. And then when I divide 18 by 6, I'm going to end up with 3. So now I just factored out a GCF. All right, so now let's look at another one, and we'll look at having a variable thrown into the problem that we could actually factor out. Let's say we have 40x to the 8th y plus 64x to the 4th y. So once again, let's just focus on taking out a GCF from 40 and 64. So what's the biggest number that I could divide out of 40 and 64? And hopefully we know that's 8. Because if I divide 40 by 8, that's 5. 64 by 8, that's 8. And 5 and 8, if I just take 5 and 8 and take a look at those don't have a common factor other than 1, so I'm good to go. All right, so now this is where things get more interesting. Let's look at x to the 8th and x to the 4th. Now, both of these terms do have x, which means I can factor out an x. However, I want to factor out the lowest exponent. So the lowest exponent is pretty obvious. 8 and 4, the lowest exponent is 4. So I can divide out x to the 4th. All right, now let's do the same thing with y. Now, both of these terms have y, and the lowest exponent really is in a confusing part. Well, it may be a little confusing, but when you actually look at it, it's not too bad. Y is to the first power, and this y is to the first power. So the highest exponent is just, or the lowest exponent is just y to the first. So I can factor out a y. So now, let me rewrite all this just so I can clear it up and show you what we do next. So we have 4x to the 8th y plus 64x to the 4th y. And we just said our GCF is going to be 8x to the 4th y. Now, that's what's going to go on the outside of my parentheses. And then what goes on the inside is when I actually come back and divide that 8x to the 4th y. So now, 40 divided by 8 is 5. X to the 8th divided by x to the 4th. Remember, when we divide and we have exponents, we subtract those exponents. So that would leave me with x to the 4th. And then y divided by y is just 1, so those two cancel. So then I'm going to bring down my plus sign. 64 divided by 8 is 8. X to the fourth is going to cancel with x to the fourth because anything divided by itself was 1. And then y over y cancels again because anything divided by itself is just 1. So then here is my answer. I factored out an 8x to the fourth, y, then I was left with 5x to the fourth plus 8 in my parentheses, which we could move. We can move that over here. All right, so that's factoring out a GCF. Now, let's make this note before we move on. I would be sure any type of factoring you want to check for a GCF first, because there are problems that we'll see where if you don't factor out a GCF first, it can complicate your problem. So the first line of thinking is always check for a GCF first. All right, so now let's switch gears and let's go to another type of factoring. Now, this type of factoring is called difference of squares. Okay, so difference of squares. And difference of squares is set up like this. You basically have, let's just say, a squared plus, or actually minus, b squared. Here's what we end up having with this setup. A squared is a perfect square. B squared is a perfect square, and they're being subtracted. So that's the setup for difference of squares. You have two perfect squares, and there's subtracting in the middle. Now, here's how this factors. You take whatever your a squared is, and you actually do the square root of that. If I did the square root of a squared, it's just a. So you take a out, you take b out, because you also take the square root of b squared, and you put those together in a parentheses, and they're subtracted. And that's the first factor. The second factor uses the exact same a and b, but now you add those two. So this is how we factor difference of squares. So now let's look at a problem. Let's say I have x squared minus 4. So once again, our setup, we're looking for subtraction, and then we're looking for two perfect squares. If I did the square root of x squared, that's x. So that is a perfect square. X squared is a perfect square, and the square root is x. Then I look at 4 and say, okay, well, what's the square root of 4? Well, that's 2. So 4 is a perfect square, and the square root of that is 2. So when I factor this, I write x minus 2. That's my first parentheses. My second parentheses, I still use x and 2, but now I make it plus. And now that's factored. All right, so let's look at another one just so you can get the idea. Let's just say I have y squared minus 81. All right, so try to factor that with difference of squares. Well, first of all, y squared is a perfect square. The square root of that is y. 81 is a perfect square. The square root of that is 9. And then if we have subtraction, that's what we need. That fits into the category of difference of squares. So y minus 9 is my first factor. My second factor is y plus 9. So there we go. Let's do one more just so you can get the idea. Let's say I have, we could even throw some x's and y's in here. We could say 9x squared minus 25y to the fourth. Once again, this may be a little confusing, but 9x squared, you could do the square root of that. Square root of 9 is 3. Square root of x squared is x. So 3x is the square root of 9x squared. So that means 9x squared is a perfect square. We have our subtraction here, so we're good on that. Now let's do 25x to the fourth. Well, square root of 25 is 5. The square root of y to the fourth, we basically just divide this exponent 4 by 2, and we say that's y squared. So 5y squared is the square root of 25y to the fourth, which means that's a perfect square. So now this is one factor. My second factor would still use 3x and 5y squared, but now I just add in the middle. So then there are my factors. Now, if you noticed, difference of squares is almost like a little cheat code. It's basically a cheat for factoring. you can only do difference of squares, once again, when you have a squared minus b squared, meaning two perfect squares that are subtracted. However, once again, even if you're doing a difference of squares problem, always check for a GCF first. You're going to hear me say that a lot. So check for a GCF first. All right, now let's move on to another type of factoring. This type of factoring is called trinomial factoring, and here's the setup. Ax squared plus bx plus c. Basically, I memorized the x squared, x, and then a number. If I see that setup, I start to think, okay, this is that trinomial type of factoring. Now, the first problems we're going to do are when a is equal to 1. Basically, it's going to look something like this. X squared plus 14x plus 45. So it's going to look something like this. So now, let's actually look at that problem, and we'll start to go through these steps. So this requires a very specific set of steps. I call this method the product sum method. Some people call it something different. I call it the product sum method. So here's what we actually do, and I'll show you this with A's and B's and all that. So AX plus BX plus C. Here's what we want to do. We want two numbers that multiply to give me C. All right. And then they add those same two numbers. Then they add to give me B, which I wrote C twice. It's B. There we go. All right. Now, if we take all of that and we kind of just get rid of the A, B's, and C's, let's look at our problem. So our problem says x squared plus 14x plus 45. Now, we obviously have this plus 14x, so we can't really even think about difference of squares here. Difference of squares, usually you only have two terms, and this has three terms. So that's out. Let's check for a GCF. X squared, x, and 45 doesn't have an x, which means x squared can't be factored out. This coefficient is 1. 1, 14, and 45. The biggest number you could divide all those by is 1. So that's out the window of a GCF. So now we have to turn to this product sum method. Now, in this case, C is 45. So what I want to do, and you can actually set this up, you can say, I want two numbers that multiply to give me 45. But I want those two numbers to add to give me B, or combine to give me B. And B in this case would be 14. So let's start just rolling through some numbers. So let's say we did 1 and 45. Well, obviously 1 plus 45 is not going to work here, so that's out the window. Let's think for a second. What two numbers multiply to give you 45? I hope there's an obvious one that sticks out. It would be 9 and 5. So now, when I pick 9 and 5, here's all I'm looking for next. Does 9 plus 5 add together to give me 14? Well, it does. So then here's how we write this, these factors. Some people call this reverse foiling. Once again, I just call it the product sum method. It's up to you on what you want to call it. The first thing we're going to do, we know factors are going to be multiplied, and we're actually multiplying two parentheses. Now, we're going to start both of these parentheses off with x, because imagine we did FOIL this. We would end up doing x times x to give us x squared. So that's the first part. The first part is you need both your parentheses to start with x. Then you're going to take 9, and if it's a positive 9, you're going to say plus 9 in one of your parentheses. And if it's a positive 5, you're going to say plus 5 in our parentheses. Now, here's why some people call this reverse FOIL. If you were to multiply this back out from here, you would end up with x squared plus 14x plus 45. If you don't believe me, you can do it. You can FOIL this out, and you will end up with x squared plus 14x plus 45. So once again, the product sum method will always end up happening that way. But here's the only thing about the product sum method. You need to make sure that a is equal to 1. As long as a is equal to 1, you're good to use the product sum method. So let's look at another example. And let's actually make this a little bit harder, because now we're going to start flipping some of the signs around. So w squared minus 15w plus 26. All right, so when we look at this problem, we want to, once again, we want to check for a GCF first. W squared, W, and 26 doesn't have a W, so that's out the window. This coefficient is 1, so factoring out a GCF is out the window. Now, this is a setup, since it's 3 terms, for this trinomial factoring, the product sum factoring. Once again, we just want to double check that this lead coefficient for x squared is 1, and it is. So now here's what we can do. We can think of 2 numbers that multiply to give me 26, but I want those numbers to add back to actually give me negative 15. So here's what that means. In this case, we're actually going to need negative numbers. So think about it this way. Let's just first, let's pause for a second. Let's just find our numbers, and then I'll explain it a little bit better. So 26. Well, let's just not even think about 15. Let's just think about, or negative 15. Let's think about positive 15. What 2 numbers could multiply to give you 26 and then add to give you 15? Let's just start there. Well, I could do 13 times 2. That gives me 26. And a positive 13 times a positive 2 gives me positive 26, so I'm good there. Now, here's the tricky part. If I did 13 plus 2, that gives me positive 15. But what if I made both of these negative? Would that work? Well, let's check. A negative times a negative is a positive, right? So negative 13 times negative 2 does give me negative 26, or positive 26. So I'm good there. Does negative 13 plus a negative 2 give me negative 15? Yeah, it does. Because negative 13 minus 2, that's the same thing as plus a negative 2. If I do that, that does give me negative 15. So this is a good point to go ahead and see. Sometimes you have to mess with these signs in order to make your factoring work. And that's just a skill that once you get used to doing this, it gets a little bit easier to practice, or to boost that skill, or build that skill. All right, so now our 2 factors would be w minus 13 times w minus 2. Because once again, we need the w's to lead the parentheses to give me w squared. And then we need to just take our negative 13, put it in our parentheses, negative 2, put it in our parentheses. Let's look at one more, just to give you a clear picture of how this can work. So let's say I have c squared. Let's change this to x squared plus 2x minus 48. So first, answer me this. Could I factor a GCF out of this? No. X squared, x, and no x means I can't factor out an x. The lead coefficient is 1, so I can't factor out a number bigger than 1. So I have to use my product sum factoring, or some people call it reverse FOIL. Okay, now this type of factoring, once again, we're going to look at the last number, negative 48, and we're going to look for 2 numbers that multiply to give me negative 48 and add to give me 2. Now, hopefully this is a dead giveaway. These signs are going to need to be alternating, because the only way I can multiply 2 numbers and get a negative is if one is a positive times a negative. So that's your tip-off that we're going to have to alternate our signs here. So now let's think of some numbers that multiply to give me 48. And the one that immediately pops out to me is 8 and 6. Well, you may say, well, 8 plus 6 gives me 14. But remember, I need one of these signs to be negative, because I can't do 8 times positive 6 to give me a negative 48. So one of these 2 numbers needs to be negative. Let's try to figure out which one it would be. So if I want a positive 2, basically what I'm asking myself is this. Would negative 8 plus 6 give me positive 2? No. Negative 8 plus 6 would give me negative 2, and I don't want that. What I want is 8 minus 6, because that would give me a positive 2. So the 8 is positive and the 6 is negative. So then I would factor this and say, okay, my two parentheses are both going to start with x. I'm going to take positive 8 and make it plus 8. I'm going to take negative 6 and make it minus 6. And that's how I would factor this. All right, so now let's look at the last type of factoring. The last type of factoring, at least for this video, is the same trinomial factoring, but here's going to be the issue. This a is going to be greater than 1. All right, so if a is greater than 1, this method is called a couple different things, but let me rewrite this and just show you what we do. So ax squared plus bx plus c. What you end up doing, some people call this slip and slide. That's probably a really good way to describe it. I call it the bottoms up method. Some people just call this reverse foiling. But here's essentially the main takeaway. If this lead number is bigger than 1, we actually are going to have to multiply that number to the end. So you end up doing a times c, and then that's your first step, okay? Now, the big trick here is you have to remember, if you're going to do that, you have to come back at the end and divide by whatever that a value is. Now, let's actually look at some problems, because it's a lot easier to show you with problems. Just saying it's, I don't know, it doesn't help as much to just show it. So we have 2x squared minus 15x plus 18. So now our first step would be this. If I could, I would want to get rid of this 2 if I could factor out a GCF. So let's check for a GCF. First of all, 2, 15, and 18. Is there one number other than 1 that you could multiply or divide 2 by, 15 by, and 18 by? No. So a GCF is out the window because this 18 doesn't have x, which means I also can't factor out an x. So I'm pretty much stuck. I'm stuck with this 2 in front of x squared. Now, if that happens, once again, some people call this slip and slide. Some people call this bottoms up. Here's what we have to do. You're going to take 2 and you're going to multiply it to the end by 18. And you're going to rewrite the problem. X squared minus 15x. But now you're going to do 2 times 18, which gives you 36. Now, what you can't forget is, at the end, when I factor this, I need to come back and divide by that 2. That's the big part of this that you can't forget. All right? So some people say, I'm going to slip and slide 2 down to the end. Once again, I say bottoms up, which doesn't apply here. I just know to multiply 2 by 18. So there's a couple different methods. But now that we're to this step, now you can see there's no number in front of x squared that we can see, so it means there's a 1 there. Well, that's the setup for that product sum factoring. So the reason we multiply this lead number to the end is so that we can do the product sum method to the second step. We need 2 numbers that multiply to give me 36, but add to give me 15. And it needs to be a negative 15. And I'll tell you, 12 and 3 are going to work, but 12 plus 3 is positive 15. So what does 12 and 3 need to be? They need to be negative. So then I'm going to rewrite this and say, x minus 12 times x minus 3. Now, I have to make sure now I come back and I divide by 2. Because once again, the big idea here is that we're multiplying this 2 by 18 at the beginning, but then we have to undo that at the end, so we have to divide by 2. So now we're going to say x minus 6, because 12 divided by 2 is 6. Now, here's my issue. X minus 3 over 2, that won't simplify. 3 divided by 2 doesn't really, it doesn't divide to give me a whole number. So this is why I call this method bottoms up. Because you take the bottom of this fraction 2 and you move it in front of x. So this becomes 2x minus 3. That's how we factor this. All right, let's look at another one. So let's say I have, oh, let me find a good one. Let's do this one. Let's say 12x squared plus 5x minus 2. So once again, let's try to factor out a GCF first. So, because we know this number 12 is in front of x squared, which is almost a tip-off, hey, I can't do the product sum method straight away, but I could try to factor out a GCF. So x squared, x, no x means I can't factor out an x. Is there a number other than 1 that divides 2, 5, and 12? No. So I'm stuck with 12 stuck in front of x squared. So this is where I can use either the bottoms up, or some people once again call it like slip and slide. We're going to take 12 and we're going to multiply it to the end by 2. All right, and then we're going to actually rewrite the problem. X squared plus 5x minus 24. Okay, now what I like to do is go ahead and make myself a little arrow that points down here and says divide by 12, because I can't forget to do that step. So now, once I'm here, this is the setup for the product sum type of factoring, because there's no number in front of x squared now. So I need two numbers that multiply to give me negative 24 and add to give me positive 5. One of those numbers has to be negative because this is negative. So I need alternating signs. Now, I know 8 and 3 are going to work, but one of those has to be negative. Would the 8 or the 3 be negative to give me a positive 5 when they combine? The 3 would be negative. So we would say x plus 8 times x minus 3. Now, some people will say, I'm done, I'm finished. But remember, if we multiplied by 12 at the beginning, now we have to undo it and divide by 12 at the end. So we're going to divide both of these numbers by 12. And this is going to give me x plus, let's see, is that 4? No, 2/3. That's going to give me 2/3. And then 3 over 12 is going to give me 1/4. Now, once again, if we're strictly factoring, we don't really want these fractions here and here. Some people may be okay with it, but most people I've seen aren't okay with it. So once again, this is why I call this the bottoms up method, because it helps me remember I take the bottom of this fraction and move it to the front of x for each of these. So this actually would look like this: 3x plus 2, 4x minus 1. And now I'm finished. Now, I know this is a lot of material, but this video's used, it's supposed to be a complete guide to this. There may be a couple things here and there that you may have to work on, like factoring out a GCF or something like that. But if you need any extra help, just reach out. And hopefully this video was pretty helpful. So you can let me know if it was or wasn't and all that.